So far you have gotten the idea that we use the value of the discriminant to decide the nature of the roots, or using the nature of the roots, we deduce the value of the discriminant. So it can be both ways. So right now we are going to be explaining these are the explanation questions. So we will be explaining why equation has real roots, why equation has no roots. So the approach to explain such question is to use the discriminant. So when they say show, it is the same as explaining. Okay, please change this to example 8. Okay, and subsequently this one should be example 9. Okay, so these two examples will illustrate how we use the discriminant to explain. So if you see that it's an explanation question, we got to use the discriminant and deduce a certain value so that we can explain it. Okay, so the approach will be very simple. Okay, so for example, in this question, I'm going to explain why it has real roots. So I got to use the discriminant. So in order to use the discriminant, I make sure I got my ABC first. So you do your expansion carefully. So do your expansion very carefully. Bring everything over to one side in such a way that you can be getting your ABC. Okay, why are you getting the ABC? Because you know that you need to get your ABC to come up with the discriminant. So the discriminant is like a tool for us to explain. So I gotten my A, I gotten my B, I gotten my C. So I need to use the discriminant. It's a bit like example 3. So I'm going to explore how my discriminant looks like. Okay, my discriminant looks quite ugly because it's quite a lot of algebra, if you realize. So B squared minus 4AC. It's not like in example 3 where you just get a nice value that you can punch calculator. So this one is a bit difficult. So what you need to do is you got to simplify the expression first. So do your algebraic expression. So eventually you get a quadratic function. When your discriminant is a quadratic function, you got to approach it by the completing square idea. So factorize out the 9 so that you can execute your complete square. So if you didn't manage to get a value for the discriminant, instead you got a quadratic function. So this is a quadratic function in P. So I'm going to be completing square in P. So do your usual completing square. So I'm not explaining the completing square. I assume your technique of completing square will be okay. So this is my discriminant. My discriminant is not a value. It is an expression. So I got to deduce out the value of the discriminant from the expression. So it's not like example 3. If I got a negative value, then straight away I know that the discriminant is negative. So right now I couldn't tell. So I need to deduce. So we deduce it from the perfect square. So any perfect square will be always positive. Because if you square any number, even the negative number become a positive number. So I'm trying to achieve the expression for the discriminant. So there is a 9 besides the perfect square. So I'm going to multiply 9 on both sides. So 9 is a positive number. You shouldn't change the inequality sign. Okay, and I need to add the 32/9 on both sides. So I couldn't tell the value of the discriminant. I got to deduce it out. I deduce it using the perfect square. So finally, this is my discriminant. And if you punch a calculator on this side, you will get 32/30, 32/9. Is it correct? Yeah, it's correct. So what is the implication? So by the time you hit this, right, the implication will be, okay, what should be your thinking? So your thinking will be, so you couldn't tell the exact value of the discriminant, but you know that the value of the discriminant will be, it will be this or more. So in other words, okay, that also implies that the discriminant is always positive. So in a way, the discriminant turns out to be positive. So what is the implication of a positive discriminant? That means, right, the equation has real roots. Okay, so it's a bit like example 3. Example 3 is very simple because we got the actual value of the discriminant. When you do not have the actual value of the discriminant, instead you got an expression for the discriminant. You got to deduce the value slowly. So for this question, right, I managed to deduce it because I got a perfect square. I'm using the idea of a perfect square to deduce a value. And actually, I'm not getting the exact value. I only know that the value will be this or more. So whatever is it, this value or more will just imply that you will always get a positive value for the discriminant. And that is the reason why the equation has real roots. Okay, so this is a very long question. This is quite a common technique. They always like to incorporate complete square in the explanation question. Okay, the next one is the same thing. I need to show that the roots are not real. So the showing is like explaining. So I need to explain why the equation doesn't have real roots. So the condition for real roots will be the discriminant being negative. So again, I'm going to approach it by taking the discriminant, by using the discriminant. So if I want to use the discriminant, again, right, I got to get my ABC correct first. So I need to execute my ABC. So you need to expand out very carefully and make sure you group them correctly. So make sure you are able to group them in such a way that you can compare your ABC. So B is always the coefficient of X. B is always the constant. So in constant means it doesn't contain X. So 3p squared doesn't contain X. So once you get your ABC, let's explore the value of the discriminant. So it seems like you're not getting a value of the discriminant. So you got to do your basic expansion. So this is your expression. So this is the expression of the discriminant. So again, I couldn't tell the value. It doesn't outright tell me what is the value. Okay, I don't get a numerical value for it. So I got to deduce. So I got to deduce from the condition given to us. So I got to deduce the discriminant from the given condition. So there is a minus 12 inside the expression of discriminant. So you multiply both sides by minus 12. And because you're multiplying by a negative number, you reverse the sign. And there is a plus 1 in the expression of your discriminant. So you plus 1 on both sides. Finally, you deduce that this is your discriminant and your discriminant is negative. So you manage to deduce out. That means it's not a direct situation. You couldn't tell the direct value. So you actually deduce out because they gave you a condition. So the equation has no real roots. So it's a bit indirect where you will need to explain roots. So these are the one of the things that a lot of students find very difficult to explain. Whatever is it, we approach using the discriminant. It's just that you may be faced with different expression of the discriminant.